All right, let's go through our review for the circles test. Here we're starting with arc length. All right here. And anytime you see arc length, you are going to want to use the arc length proportion, which is the ratio of arc length out of circumference, and that's equal to the ratio of the central angle out of 360 degrees, because 360 represents all the way around the circle. All right, so in our first problem, we have let's go ahead and label our parts. We have a radius here of 11 miles, and we have a central angle here. That's 120 degrees. We're going to try to find the arc length. The arc length right here. Okay. So let's fill in our proportion. Let's start with, we're going to put x here. That's what we're going to try to find for arc length. Below that is circumference, and our formula for circumference is 2 pi r. We know our radius, so 2 pi times 11. And so our circumference is 22 pi. And then on the other side, they gave us the central angle is 120 degrees, and that's out of 360. All right, and now we're going to go ahead and solve this proportion. So again, we can cross multiply. We get 360x equals, and then on the other side, 22 pi times 120. And then we're solving for x. So we're going to divide both sides by 360. The 360s cancel each other out. And so x, our circumference, or sorry, our arc length is 22 pi times 120 divided by 360. When we put that in our calculator, we get an arc length. So x, the arc length, equals approximately 23.04 miles. Okay. All right. Go ahead and try number 2A. Again, we're given the radius. We're given the central angle. You're going to make your proportion. Go ahead and try that on your own. You can pause the video. I'm going to show the answer for that one. All right, so the answer for number 2 is here. All right. Double check how you got that. And again, you'd set up a proportion just like we did on number 1. Let's go down to the sector area problems now. And we're doing the sector area of 120 degrees, so we're using this circle again. All right. And for sector area, we're going to set this up pretty much the same way as our arc length, but instead the proportion becomes sector area. So again, it's a sector area. It's a ratio out of the area, and we're going to use pi r squared for our area. And then on the other side, it's the same as arc length. You have your central angle over 360. All right, so we're going to set this one up pretty much the same. We're trying to find sector area. I'm going to put that as my x. All right, and this time we're using, again, for this problem, radius is 11. And so area equals pi r squared. In this case, that's area equals pi times 11 squared. So 11 squared makes 121. We have 121 pi on the bottom. Our central angle is still 120 degrees out of 360. And same as before, we're going to solve that proportion for x. I'll let you try that on your own. You should get an answer for our sector area x. It is 126.71 miles squared. All right. And again, sector area, that would be the area of this slice of pie. Okay. Go ahead and pause if you want. I'm going to show the answer for number 2B, the sector area of 60 degrees. And here is the answer for 2B. All right, double check to see if you got the same answer as I did. All right, let's move on to our next problem. Here on number 3 and 4, we are, you'll notice we are given an arc length in both of these. And so if you're given an arc length and you're trying to find like a missing radius or central angle, you're still going to use that formula or that proportion, which again is arc length over your circumference equal to your central angle over 360 degrees. All right, and so what we want to do is for 3 and 4, after we draw a picture like I did here, we want to fill in the parts of the proportion that we know. So we're given an arc length of 40 inches. We know the central angle for number 3 is 135 degrees, and we are trying to find the radius. So what I know is circumference equals 2 pi r, and circumference has the radius in it. So when I put this formula here for circumference, because we don't know the circumference, but you'll notice the only variable that we don't know in the proportion now is r. So we can solve this proportion for r, the radius. All right. And so to do that, what we're going to do is we're going to start by cross multiply. We get 40 times 360. On the other side, I get 2 pi r times 135. Again, I'm trying to isolate my variable r. So I'm going to divide by everything that isn't r on this side. And I'm going to do the same thing here to balance this out. All right. And the 2, the pi, the 135 all cancel out. And I'm left with r on my right side. And plug that into my calculator on the left side. And I get a radius of about 16.98 inches. All right, if you didn't get 16.98 inches when you plugged the left side into your calculator, remember you can put parentheses around the denominator. That way your calculator follows order of operations correctly. Same idea for number 4. All right, so on number 4, we're going to start with, again, this proportion because they give us an arc length. We have a radius. We're trying to find a central angle. Those are all part of that proportion. So let's go ahead and set it up. My arc length is 18. We know the angle is supposed to be at 360 degrees. All right. We are given a radius here. So since we're given the radius, we can find our circumference. So this is 2 pi times 8, and so our circumference is 16 pi. All right, and we're trying to find our central angle, and that would be theta. Okay, and so same as before, I'm going to go ahead and cross multiply. 18 times 360 equals, over here we get theta, what we're solving for, times 16 pi. And we want to get theta by itself, because that's what we're trying to solve. So I'm going to divide by the other numbers there. Again, I cancel out my 16 pi on the right side. So my angle theta is going to be 18 times 360 divided by 16 pi. And so you get an answer for the central angle, which is theta, is approximately 129 degrees if you round to the nearest whole number. Boom. All right, let's move on to angles now. Find the measure of the arc or angle indicated. So when we get these problems, we want to go ahead and trace what we have. We have an inscribed angle here. So that's an inscribed angle, and 78 degrees, that is an arc angle. And what do we know? Inscribed angle is half of a central angle and an arc angle. So if we're given the arc angle is 78, then the inscribed angle, QRP, is going to be half that. So I'm going to do 78 divided by 2, and I get 39 degrees. All right, so same idea on number 6. We notice we are given this inscribed angle, and this time we want to find the arc angle. And so all we're going to do is we're going to take 39 degrees. The arc angle is twice as much, so I'm going to times it by 2, and boom, that one's 78 degrees. All right, let's practice a few more angle problems. Let's go to number 7 and 8. I'm going to do number 7, and then I want you to try number 8 on your own. For number 7, what we want to do first is go ahead and see what we're given. We're given this angle is 51. So let's trace this angle. That's an inscribed angle. All right. So I notice this inscribed angle matches with this arc angle here. That arc angle is going to be twice as much, so that must be 51 times 2. That's 102 degrees. All right, and I notice that's arc angle VN. So we just found VN is 102 degrees. We're also asked about VNX. So VNX is here. And I notice VNX when I look to see what's connected with it. I notice this is a diameter. So VNX connects with a diameter, and a diameter cuts a circle in half. That also means it cuts 360 in half. It's 180 degrees. So diameter, in this case, this is a central angle is 180 degrees. That means what I trace here in blue, this arc, is also 180 degrees because it's half of the circle. It's halfway around the circle. And so now we can see we're trying to find the last one, NX, and NX goes from here to here. It's an arc angle here. And I know already that the total of this blue arc angle, VNX is 180, and VN in red is 102. And so whatever is left to add up to 180 is NX. So just a little math, we're doing 180 minus 102, and that gives me NX is 78 degrees. All right, go ahead and pause right now, and I'm going to show the answers for number 8. I want you to try that on your own. All right, here are the answers for number 8. Again, try this one on your own. Again, always the key is you're going to want to start with your inscribed angle. You're going to want to trace the arc angle that matches with it. So the first one I did was the inscribed angle is 100 degrees. I know this arc angle here in green has got to be 200. And then I kind of went from there to find the other missing parts. All right, again, try it on your own and see if it makes sense. Once you go ahead and pause the video, I got numbers 9 and 10 on your review sheet coming up next. All right, and here are the answers for 9 and 10. Again, same idea, putting it all together. Trace your inscribed angles. Notice the arc angle is twice as much. Also look for diameters. Diameters are going to cut the circle in half, 180 degrees. All right, take a look at 9 and 10, and then we're going to go to our graphing problems next. Here we go. You can see I already did number 12. Let me go through number 11 real quick. So for number 11, we need to remember our equation for circles is x minus h squared plus y minus k squared equals r squared. H and k, that is the center of the circle, and r is the radius. So the first thing that we want to do is find our center of the circle. And so the center of this circle, here this says x plus 4, so h is negative 4, the opposite. And y minus 2, k is going to be just 2. That's my center. I'm going to go ahead and find negative 4, 2. Negative 4 on x, up 2. There's my center. Then I want to find my radius. So the r squared is 9. I square root both sides, I get r is 3. So my radius up, down, left, and right is going to be 3. And there is my circle for number 11. All right. Go ahead and pause the video and try numbers 13 and 14 on your review sheet. And here are the answers for number 13 and 14. Again, I started by finding the center. Then I found the radius and graph my circle. 5 points in total. Let's keep going, and you can see that I did number 16 for you. So let's go through number 15 together, and then we'll finish our review with number 17. Again, we're given the center points, that's our h and k values. So we start with our original equation of a circle. And we basically just fill in what we have. We have x minus a negative 12 squared plus the next one is y minus a negative 4 squared, and then my radius is 4. So I got 4 squared. Now I just want to simplify it. These two minus a negative becomes positive. So it's x plus 12 squared. Same thing here. This simplifies to y plus 4 squared. And then 4 squared is 16. That's my equation of the circle. I'm going to do a similar thing here for number 17. They give us the center. That's my h and k value. They don't give us the radius, but they give us a point on the circle. I'm going to make those my x and y values. All right, and so if I plug all of these into my equation of the circle, I get negative 13 minus a negative 10 squared plus 10 minus 6 squared equals r squared. And you'll notice the only variable we have left is r. And that's the thing that we need to figure out, the radius, in order to finish our equation. So we're going to go ahead and simplify this on the left side. This becomes negative 13 minus a negative 10. It's the same as negative 13 plus 10, which is just negative 3 squared. And then 10 minus 6 is 4. It's 4 squared. We still don't know what the r squared is. but I do know negative 3 squared is negative 3 times negative 3, that's 9. 4 squared is 16. And so now we got r squared is equal to 25. All right, so I'm going to just write out now. I know what my r squared value is. That makes my r 5. I can now do the rest of my equation. So this is going to become x plus 10 squared plus y minus 6 squared equals 25. That's the equation of the circle for number 17. All right, good luck on the test.